Today we delve into the mesmerizing ultra-deep images of Oroxia 2, the hot Jupiter that has captured the world's attention. Prepare to be amazed by the extraordinary discoveries made by the James Webb Telescope as we navigate the mysteries of this fascinating exoplanet. You'll be left in awe by what lies beyond our reach. Hot Jupiter. According to research conducted by the James Webb Space Telescope, the atmospheres of gas giant planets found throughout the Milky Way galaxy can be very distinct from those found in our own solar system. The faraway exoplanet HD 149026b, also known as Smertrios, was the subject of observations that revealed that the atmosphere of the planet is abundant in what scientists refer to as heavy elements. Heavy elements are essentially any elements other than hydrogen and helium. The James Webb Space Telescope found that the atmosphere of Smertrios contains a significant amount of carbon and oxygen in high concentrations. The findings have astronomers scrambling to make sense of them. In the gas giant planets of our solar system, such as Jupiter, Saturn, Uranus, and Neptune, scientists have observed a direct relationship between the mass of the planet and the quantity of heavy elements present in its atmosphere. There will be lower concentrations of these elements in a planet's atmosphere if that planet has a greater mass. According to Jacob Bean, a professor of astronomy and astrophysics at the University of Chicago and the lead author of a new paper describing the observations, who was quoted in a statement as saying, "The giant planets of our solar system exhibit a nearly perfect correlation between both overall composition and atmospheric composition and mass." The observations were described. Even though astronomers have seen more diverse atmospheric compositions in gas giant exoplanets in the past, the atmospheric composition of HD 149026b is completely unprecedented. The planet is the mass of Saturn, but its atmosphere seems to have as much as 27 times the amount of heavy elements relative to its hydrogen and helium that we find in Saturn. Study co-author Jonathan Lunin, a professor in the Physical Sciences Department at Cornell University, said in the statement, "Lunin is part of a research team that discovered the planet. HD 149026b, also known as Smertrios, is a so-called hot Jupiter, which refers to a planet that is similar to Jupiter but that orbits its parent star at an extremely close distance. In the case of Smertrios, this distance is so small that the duration of an entire year on the planet is equivalent to just 3 days on Earth. Because Smertrios is so close to its star, the temperatures in its atmosphere can reach a blistering 2700 degrees Fahrenheit. This is approximately 3 times higher than the surface temperature of Venus, which is the planet with the highest average temperature in our solar system. This, on the other hand, does not account for the peculiar makeup of the planet's atmosphere. According to Lunin, it seems that each giant planet has its own unique characteristics, and we're beginning to see those characteristics thanks to JWST. In this paper, we have determined how many molecules there are in comparison to the primary component of the gas, which is hydrogen, which is the most prevalent element in the universe. That reveals to us a significant amount regarding the formation of this planet. Scientists are able to gain insight into the chemistry of a planet's parent star and the material from which it formed by analyzing the composition of a planet's atmosphere. This insight can be gained over a period of millions or billions of years. According to the findings of the study, the planetary disk that gave birth to Smertrios must have contained a much higher ratio of carbon to oxygen than the disk that gave birth to our solar system. In the coming year, the researchers intend to conduct research on additional hot Jupiter planets in the hope of identifying statistical trends that underlie the variations in the chemical compositions of these planets. Warm Jupiter. Exoplanet described as being warmer than Jupiter discovered by a NASA satellite. A warm planet that is twice as massive as Jupiter and orbits a distant dwarf star has been discovered by scientists. If another planet acts as a cosmic matchmaker, the extrasolar planet, also known as an exoplanet, may be on its way to becoming a so-called hot Jupiter by snuggling up to its host star. However, this will only occur if the extrasolar planet has a companion planet. This newly discovered exoplanet, which has been given the designation TOI 4127b, takes 56.4 days to complete one orbit around its parent star, TOI 4127. Its mass is 2.3 times that of Jupiter, and its radius is nearly 1.1 times as large as Jupiter's. The highly eccentric orbit of the exoplanet brings it to within about a third of the distance between Earth and the Sun from the star, and the fact that its surface temperature is nearly 630 degrees Fahrenheit means that it is classified as a warm Jupiter. The team, however, believes that this might not be the case for much longer, based on their analysis of TOI 4127b's property. Astronomers believe that the planet has the potential to evolve into a hot Jupiter, but this is only the case if the orbit of another celestial object is disturbed. A group of astronomers made the discovery of the exoplanet TOI 4127b by making use of NASA's Transiting Exoplanet Survey satellite. TESS is currently conducting a survey of approximately 200,000 bright nearby stars in an effort to identify any exoplanets that may orbit around them. From its vantage point in a 13.7-day highly elliptical orbit around Earth, TESS is able to accomplish this by observing the extremely minute drops in light intensity that are caused when these planets transit in front of their respective host stars. The TESS satellite, operated by NASA, is highly skilled at detecting planets with short orbital periods that complete one revolution around their star in less than 13 days. This is due to the fact that the telescope has an observation period of 27.4 days, and a minimal orbital period of 13 days should enable TESS to detect a planet that is transiting at least twice. This is the minimum number of transits that are required to suspect the existence of a planet. Since its launch in April 2018, the TESS has found over 6,200 exoplanet candidates, demonstrating the method's tremendous success. To date, approximately 3,000 of these so-called TESS objects of interest, or TOI, have been validated. Many of the extrasolar planets that have been discovered by TESS so far are hot Jupiters. A hot Jupiter is a world of a size comparable to Jupiter or larger that orbits its star extremely closely at distances that are roughly 1/10 of the distance that separates Earth and the Sun. TESS has discovered a number of hot Jupiters. This results in orbits that are approximately 10 days or shorter. TOI 4127b is a planet that was found by astronomers led by Pennsylvania State University that was found to be orbiting a dwarf star that was slightly more massive than the Sun and was located approximately 1,061 light-years away from Earth. Although TOI 4127b is currently located at a distance from its star that prevents this interaction from taking place, there is still a possibility that it could evolve into a hot Jupiter in the future if it is participating in a momentum exchange with a second planet in the system that has not yet been discovered. The investigation of this newly found extrasolar planet, therefore, has the potential to be the key to a better understanding of the so-called hot Jupiter formation pathways. Ultra-deep field. The near-infrared camera aboard NASA's James Webb Space Telescope captured this view of the Hubble ultra-deep field. The Webb image observes the field at depths comparable to Hubble's only 1/10 of the time, revealing galaxies of similar faintness. The JWST has been directed by NASA to focus its keen vision on an area of the far reaches of the sky that was made famous by its predecessor. The Hubble Ultra-Deep Field is a distant region located in the southern constellation Fornax, and it was recently captured on camera by the JWST. The Hubble Ultra-Deep Field has long been considered by astronomers to be an extremely fertile hunting ground due to the fact that it contains at least 10,000 galaxies that date back to just 800 million years after the Big Bang. This gives researchers a glimpse into how the very first galaxies may have formed. Late in 2003, the Hubble Space Telescope of NASA conducted an observation of this region of space, and as a result, it was able to capture the very first images of galaxies located at the furthest distances ever discovered. When asked about this record, representatives from Hubble stated that it is unlikely to be surpassed until Webb takes the stage. 2 decades later, in the 2000s, the Hubble Space Telescope's successor, the JWST, was able to observe the same region at similar depths as its predecessor, meaning that Webb could see galaxies as faint as its predecessor did, but in only 1/10 as much observing time. While it took Hubble 11.3 days to capture the image, Webb did it in just a little bit more than 20 hours, breaking the previous record. The most recent image is also revealing newly discovered young galaxies that were previously hidden from view. The role of highly ionized gas in the formation of stars. In a recent statement, Professor Masita brought to light the significance of hot ionized gas in relation to the process of comprehending how stars are born within galaxies. It was he who stated, "The fact that we see hot ionized gas is telling us exactly where stars are being born in these galaxies. Now we are able to distinguish those regions from those in which stars have already existed. Because of this vital piece of information, we are able to investigate the processes that govern the formation of stars and the development of galaxies in greater depth. Even though these cosmic structures have been undergoing change for billions of years, there is still a great deal that we do not understand about how they developed into what they are today. This image, which was captured in infrared wavelengths by the powerful near-infrared camera instrument aboard the James Webb Space Telescope, is assisting astronomers in piecing together the history of the universe in the first billion years after the Big Bang. The term reionization era refers to this time period, which corresponds to the birth of the very first generation of stars. When the universe was much younger, galaxies were not as well defined as the ones we see closer to our Milky Way galaxy, which is itself a finely tuned spiral galaxy. Astronomers have previously found a galaxy in this early portion of the universe that resembles a toothpick, and they have also found a galaxy that resembles a bracelet link. What is it that Webb's image will ultimately show us? In 2004, the Hubble Space Telescope was the first to pioneer the concept of an ultra-deep field, abbreviated as UDF for short. The Hubble Ultra Deep Field is an image that was taken by the Hubble Space Telescope that covers a relatively small portion of the sky and reveals thousands of galaxies that had never been seen before. This remarkable accomplishment was accomplished by pointing the telescope at a region of the sky that appeared to be devoid of any objects for an extended period of time, which allowed it to collect dim light from extremely faraway galaxies. The Hubble Ultra Deep Field completely reshaped our understanding of the history of the universe and its development, but it also posed a great deal of questions that the JWST is now in a position to resolve. NASA, the European Space Agency, and the Canadian Space Agency are all working together on the James Webb Space Telescope. It is intended to carry on the work of the Hubble Space Telescope while also extending its capabilities. The primary mirror of the JWST has a diameter of 6.5 meters, making it almost 3 times larger than the mirror of the Hubble Space Telescope. Because of this difference in size, the telescope is able to collect more light, which is essential when attempting to observe more distant objects in the universe. The JWST has a capability to make observations in the infrared spectrum, which is one of the most significant advantages it has over its predecessor. In contrast to Hubble, which focused primarily on visible and ultraviolet light, the James Webb Space Telescope is designed to carry out observations using infrared light. This feature enables the telescope to see through dust and gas, which frequently obscure the view of faraway objects, and to investigate the earliest epochs of the universe, during which time galaxies were first forming. A revolutionary step forward, the ultra-deep field technology. The ultra-deep field technology of the JWST expands upon the achievements of the Hubble Space Telescope's UDF, but with several significant enhancements. The JWST will be able to observe even fainter and more distant objects than its predecessor was capable of doing, thanks to the advanced near-infrared camera and mid-infrared instrument that are both components of the telescope. The NIRCam will observe objects with wavelengths that range from 0.6 to 5 microns, while the MIRI will extend the telescope's reach further into the infrared, covering wavelengths that range from 5 to 28 microns. The JWST will be able to study the formation of the first stars and galaxies, which are thought to have emitted light primarily in the infrared spectrum because of the expansion of the universe. This will be made possible by the JWST's extended wavelength range. The JWST will also make use of a method known as gravitational lensing, which describes the phenomenon that takes place when the gravity of a massive object, such as a cluster of galaxies, bends and magnifies the light coming from more distant objects that are located behind it. The JWST will be able to detect galaxies that are even less bright and further away than those that are visible in the Hubble Ultra Deep Field, thanks to its ability to observe gravitationally lensed objects. Consequences for the fields of astronomy and cosmology. The ultra-deep field technology that will be used by the JWST has the potential to completely transform our view of the cosmos. The telescope will provide insights into the earliest stages of galaxy formation and evolution that have never been seen before. These insights will be gained by observing the most distant objects in the universe. Scientists will be able to answer fundamental questions about the nature of dark matter, dark energy, and the overall structure of the universe with the assistance of these observations. There is no doubt that the JWST's ultra-deep field technology will motivate a new generation of astronomers and people who are interested in space, in addition to having an impact on scientific research. The breathtaking images that are going to be produced by the telescope will serve as a striking reminder of how vast the universe is. All this research may be old. The role that time dilation, a consequence of Einstein's theory of relativity, plays in the discoveries made by the JWST is one of the most fascinating aspects of those discoveries. Time slows down as a result of the expansion of the universe, which, combined with the fact that the speed of light is limited, makes it take longer for light to travel to us from more distant objects. As a consequence of this, when we look at galaxies in the far distance, we are seeing them exactly as they appeared billions of years ago. Since the beginning of time, the light emitted by these objects has been moving through space, carrying with it information about the history of the universe. The new discovery seen through a contradictory lens. It is important to keep in mind that even though the JWST is making new discoveries about the cosmos, these findings cannot be considered new in the conventional sense. Instead, they give us a glimpse into the distant past of the universe and provide us with a window into that past. The galaxies that we see today through the lens of the JWST are the same galaxies that existed billions of years ago. However, the light from those galaxies is only just now reaching us after an unimaginably long journey through the cosmos. This paradoxical viewpoint presents a challenge to our understanding of time and space, which in turn serves to bring to our attention the immensity of the universe as well as the bounds of our comprehension. Even though we are ecstatic about the groundbreaking discoveries that the JWST has made, we have to be honest and say that these findings are nothing more than a glimpse of the complicated history of the universe, the majority of which is still out of our reach. The importance of discoveries made in ancient times. In spite of the passage of time and the antiquity of the discoveries made by the JWST, the importance of these findings to humankind cannot be overstated. They provide information about the processes that led to the formation of galaxies, stars, and planets, which enables us to piece together the history of the universe and gain insights into those processes. Through the study of the distant past, we can start to get a better understanding of the fundamental principles that govern the cosmos, as well as the forces that were responsible for shaping it into what it is today. Furthermore, these discoveries have significant repercussions for our comprehension of where we stand in relation to the rest of the universe. We are reminded of the interconnected nature of the cosmos and the shared history that binds us to these ancient celestial bodies as we uncover the mysteries of far-off galaxies. As we do this, we are also reminded of our own place in this history. Discoveries made by the James Webb Space Telescope serve as a potent reminder that despite the vast distances that separate us and the unimaginable amounts of time that separate us, we are all a part of the same cosmic tapestry. There is a good chance that the James Webb Space Telescope will make new discoveries that will fundamentally alter our view of the cosmos. These discoveries are not new in the traditional sense, rather, they are ancient artifacts from the history of the universe that have only recently been brought to light as a result of the passage of time and the effects of time dilation. In light of the fact that we are celebrating the groundbreaking work of
the James Webb Space Telescope, or JWST, at NASA has unearthed previously unknown images that demonstrate that a well-known early galaxy has a companion galaxy that is obscured by its own light but is rich in star formation. The galaxy SPT 041847, which is known as one of the brightest, dustiest star-forming galaxies in the early cosmos, was the first target for the JWST. Due to the fact that it is an extremely distant galaxy, it is approximately 12 billion light-years from Earth, the gravity of another galaxy in the foreground, located between SPT 041847 and the Space Telescope, causes the light from this galaxy to be bent and magnified, which results in the formation of a nearly perfect circle known as an Einstein ring. Astronomers were able to obtain a more distinct image of SPT 041847 with the help of the JWST, and at this time, they noticed a peculiar blob of light beaming toward the galaxy's periphery. According to a statement released by Cornell University, the blob in question actually represents a companion galaxy that had been obscured in the past by the light coming from the background galaxy. Bo Ping, the lead author of the study and a doctorate student in astronomy at Cornell, was quoted as saying in the release that we found this galaxy to be super chemically plentiful, something that none of them had anticipated. The JWST alters the way we look at this system and paves the way for new research avenues into how galaxies and stars formed in the early universe. According to the researchers, earlier observations of SPT 041847 made with the Atacama Large Millimeter Submillimeter Array or ALMA in Chile had signs of the companion. However, at the time, these hints were considered as random noise. The researcher made the discovery with the help of the JWST that the companion galaxy, which is known as SPT 0418SE, is approximately 16,000 light-years away from SPT 041847. In contrast, the Milky Way's companion dwarf galaxies, the Magellanic Clouds, are situated approximately 160,000 light-years away from our solar system. Due to the fact that SPT 041847 and SPT 0418SE are so close to one another, it seems likely that they may eventually interact with one another or possibly merge into one another. Given that SPT 041847 is believed to have formed when the universe was only 1.4 billion years old, this galactic pair could, in turn, shed light on how early galaxies evolved into larger ones. Despite its young age, it is believed that the star system SPT 0418SE has already hosted multiple generations of stars. This is an interesting fact. Both of the galaxies have a mature metallicity, which is defined as a high concentration of elements heavier than hydrogen and helium, such as carbon, oxygen, and nitrogen. This level of metallicity is analogous to that of the Sun. However, the age of our Sun is estimated to be 4.5 billion years, and, according to researchers, it inherited the majority of its metals from previous generations of stars that were 8 billion years old. We are seeing the remnants of at least a couple of generations of stars that have lived and died within the first billion years of the existence of the universe, which is not what we typically see, study co-author Amit Vishwas, a research associate at the Cornell Center for Astrophysics and Planetary Sciences, said in the same statement. We are seeing the leftovers of at least a couple of generations of stars having lived and died within the first billion years of the existence of the universe. To explain the measured abundance of nitrogen relative to oxygen, which is a reliable measure of how many generations of stars have lived and died, scientists believe that the process of forming stars in these galaxies must have been very efficient and must have begun very early in the history of the universe. This is particularly important to understand because this ratio is a reliable measure of how many generations of stars have in fact lived and died. Just using binoculars or a simple telescope, one can observe a wide variety of fascinating objects such as nebulae and comets from the surface of the Earth. Yet, if you want photographs of faraway galaxies that are suitable for scientific inquiry, you will run into a problem: air. It's possible that you believe air to be transparent, but that perception is only partly accurate. Light is a form of electromagnetic wave, and different wavelengths can be associated with it. People are only capable of seeing a limited spectrum of wavelengths, which spans from 380 nanometers to approximately 700. The longer ones are seen as red by our brains, whereas the shorter ones are interpreted as violet. Because the light of these wavelengths is able to travel through the atmosphere without suffering a significant dimming of its intensity, we can claim that the atmosphere is transparent to visible light. On the other hand, the air is not so transparent to other wavelengths of light that we are unable to perceive them with our eyes. In the infrared area of the electromagnetic spectrum, which refers to wavelengths that are longer than red, a significant portion of the light that is emitted can be absorbed by water vapor as well as carbon dioxide in the atmosphere. Exactly the same thing happens with global warming. As visible light strikes the surface of the Earth, the temperature rises, and the surface then radiates infrared. Carbon dioxide in the air can absorb some of this infrared, which contributes to an overall increase in the temperature of the atmosphere. This can result in unfavorable outcomes for human beings. The absorption of this light presents a unique challenge for an infrared telescope that is located on the ground. It would be like attempting to see the sky through a cloud cover. You simply wouldn't be able to. One solution to this issue is to simply position the telescope in an environment free of air, such as outer space. Of course, with each potential solution comes a new set of problems. In this particular scenario, you actually have to mount an extremely delicate scientific instrument on a rocket and fire it off into space, which is an extremely risky endeavor. The idea of looking back in time may strike some people as odd, but it is something that is routinely done in the field of space science. Our universe is constrained by the laws of physics, with the speed of light being one of the more well-known examples of these laws. When we refer to light, we are actually referring to all the wavelengths that can be found across the electromagnetic spectrum. These wavelengths travel at a speed of approximately 300,000 kilometers per second, which is an extremely fast speed. Because light travels at such a high speed, it gives the impression of being instantaneous in our day-to-day existence. Even at these dizzying velocities, it takes a significant amount of time to get anywhere in the cosmos. When you gaze at the moon, you are seeing it exactly as it was 1 minute and 33 hundredths of a second ago. Even though we only got a brief glimpse into the past, we still have to consider this to be the past. The same holds true for sunlight, with the exception that the photons, or particles of light, that are emitted from the surface of the sun take little more than 8 minutes to finally arrive on Earth. Our galaxy, the Milky Way, is estimated to be more than 100,000 light-years in diameter. And the stunning infant stars that can be seen in the JWST image of the Carina Nebula are located 7,500 light-years away. To put it another way, the depiction of this nebula comes from a period of time that is around 2,000 years before to the time when it is believed that the art of writing was first developed in ancient Mesopotamia. Light is a type of wave that moves at an extremely breakneck speed. It would take light less than a second to travel the distance that would be required to go more than 7 times around the planet. While observing objects in space, we need to take into consideration the amount of time it takes for light to travel from the object to our eyes or the telescope. For instance, it takes the light from the relatively close-by star system of Alpha Centauri 4.37 years to reach our planet. Hence, if you observe it in the sky, you're effectively looking back 4.37 years in time. In point of fact, everything that you observe occurred in the past. You look back in time around 1.3 seconds to see the moon. Mars is 3 minutes in the past when it is observed when it is closest to Earth. The JWST is supposed to have the capability of looking more than 13 billion years into the past, all the way back to the stage in the development of the universe when the first stars were being produced. When you stop and consider it, that is very remarkable. It's fortunate that the Hubble Space Telescope is located in low Earth orbit. This makes it easy for astronauts to do maintenance on it whenever it is required. However, the JWST will be located in the L2 Lagrange point, which is a significant distance away. But could you perhaps explain the concept of a Lagrange point? Imagine the Space Telescope Hubble traveling around the planet. A centripetal force, also known as a force that pulls an object toward the center of the circle, is required for any object that is going around in a circle. The tension in a string can be thought of as the force that pulls an object towards its center when it is suspended from a string and swung around someone's head. This centripetal force that Hubble experiences is the gravitational force that is the result of its interaction with the Earth. The strength of the gravitational force exerted on an item decreases as the object moves further away from the Earth. Hence, the magnitude of the centripetal force would diminish if the telescope were to move into a higher orbit, or one with a bigger circular radius. It would take longer for Hubble to complete an orbit if it were to maintain its current circular trajectory. If we were to describe it, we'd say that it had a reduced angular velocity. The James Webb Space Telescope orbits the Sun rather than the Earth, but the concept is the same. When the orbital distance increases, the amount of time required to complete one cycle also increases. What happens, though, if you want the JWST to be farther from the Sun but yet complete a solar orbit in the same amount of time as the Earth? The telescope would also need to maintain the same position in relation to the Earth so that it could be controlled with greater ease. You are going to need to employ a strategy in order to make this happen. This is accomplished by the use of a Lagrange point, which is a point in space at which the gravitational pull of both the Earth and the Sun points in the same direction. At this point, there are two gravitational forces pulling on an object, which causes that thing to move around in a circle. As a result, it is able to achieve a greater angular velocity as it orbits the Sun. In addition to this, it maintains its steady position in relation to our globe.
Our universe is a mysterious place. The more we know about it, the more we realize that we don't know much about it. We can only suppose what was there and what happened at the dawn of time. But what if we knew about something from that time? Yes, that's right. It is possible and has already happened. The James Webb Telescope has already spotted galaxies from the dawn of time that were so massive they shouldn't exist there. Because if they're real, then it puts into question everything we thought we knew about how galaxies are formed. There's also much more surprising about them, which we are going to discuss in today's video. So stay with us till the end to unveil the mystery of the universe and learn about these prehistoric galaxies? Well, telescopes have been used for a long time to look into the basics of what we know about the universe. A telescope collects and boosts the light that things far away give off so that we can see them here on Earth. Space telescopes like the Hubble, which was launched in 1990 and is well known for that, have been an important part of the progress of science in a wide range of subfields in cosmology and astrology. Hubble has not only helped solve some of the biggest scientific mysteries of our time, like finding dark matter and figuring out how old the universe really is, but it has also shown us things we could never have imagined. The James Webb Telescope, a newer instrument, seems intent on carrying on this practice. Its upgraded infrared light detecting equipment gives it 100 times more power than Hubble, which enables it to conduct new and more in-depth investigations into space and the beginnings of the cosmos. Redshift is the name for the way light gets stretched as it travels from objects in deep space all the way down to Earth, because the universe is expanding. The redder the light detected, the farther it has gone. Hence, redness is a proximity for age. Using these tools, scientists have been able to re-examine areas seeing up to 13.5 billion years ago, about 200 million years after the Big Bang. However, what exactly have they discovered? They discovered something very strange. A group of 6 galaxies that weren't supposed to be there at that time. The Webb telescope was used in July 2022 to re-examine a region of space that was located close to the constellation known as the Big Dipper. The high-resolution photos that were collected featured 6 blotches of exceedingly bright and red dots. According to the calculations, these objects are located 13.3 billion years in the future. Yet, the items' ages aren't the only thing that sets them apart from others of their kind. The measured light intensity is actually on a galactic scale, which means that it is much stronger than the light that originates from a single point source, like a brilliant star or explosion. At first, it was thought to be an error since there are a number of different ways in which telescopes might mistakenly interpret things. For instance, gravitational lensing is a phenomenon that was initially theorized by Albert Einstein. It describes how light may be twisted by gravitational forces as it travels through space, making it look brighter than it really is. As a result of the inquiry, gravitational lensing has been rejected, leaving scientists to investigate one obvious possibility. The data that was discovered provide evidence that supports the presence of mature galaxies at a far earlier time period than the scientific consensus can explain. These galaxies are thought to have existed less than 500 million years after the Big Bang, when the universe was just 500 million years old. This is by far the closest thing to the Big Bang that we have discovered up to this point. The James Webb Space Telescope had identified a total of 6 of these enormous galaxies in its observations. Each galaxy is around the size of the Milky Way, and they all originated very quickly, within a few 100 million years after the Big Bang. Astronomers are calling them the universe breakers, as their discovery calls our entire understanding of galaxy formation into question. Erica Nelson, who is one of the researchers who made the discovery and is an assistant professor of astrophysics at the University of Colorado Boulder, stated in a statement that they were surprised by their findings. One just cannot anticipate that the early cosmos would have been capable of organizing itself in such a short amount of time. There should not have been enough time for these galaxies to develop. Cosmologists have previously estimated that the process began slowly taking shape within the first few 100 million years after the Big Bang. Although scientists do not know exactly when the first clumps of stars began to merge into the beginnings of the galaxies we see today. The hypotheses that are now accepted estimate that 1 to 2 billion years into the life of the universe, these early protogalaxies reached adolescence, at which point they started to form into dwarf galaxies, which then began eating one another in order to evolve into ones like our own. Since light moves at a constant speed across the vacuum of space, the more we stare into the cosmos, the more distant light we are able to capture, and the further we are able to view the past. When the James Webb Space Telescope JWST was used to look around 13.5 billion years into the past, scientists discovered the gigantic galaxies had already burst into life very rapidly after the Big Bang, when the universe was only 3% of its present age. In the past, scientists thought that the first galaxies appeared right after the dark ages of the cosmos. That was a period when the only atoms that existed were hydrogen atoms. Hence, the discovery of early galaxies is not unexpected. On the other hand, The galaxies that were found in the photos taken by Webb are far larger than anticipated and contain ancient stars. When Hubble and other tools were used to look at the early universe, they often found little blue galaxies that were just being born. These galaxies just started to form out of the primordial soup of the universe and are now making their first stars and structures. In general, young stars have a very vivid blue glow. When they use all their fuel and begin to cool down, stars gradually become ruddier in appearance as they age. Old red stars were not something that scientists anticipated seeing in the ancient galaxies that Webb was designed to observe. In addition, they did not anticipate discovering galaxies with masses greater than possibly 1 billion suns each. Yet, the reddish spots that were discovered in Webb's deep fields look to be 50 times more enormous than that. According to the findings of the researchers, the galaxies have such a high mass that they are in conflict with 99% of the theories of cosmology. Either the theories need to be modified, or the scientific community's knowledge of how galaxies originate needs a fundamental rethinking in order to account for this. According to astronomers, the Milky Way creates around 1 to 2 new stars every single year. Throughout the whole of the universe's existence, at least some of these galaxies would need to have been producing hundreds of new stars every single year. Even if just one of these galaxies turns out to be genuine, it will force us to the edge of our current knowledge of cosmology. Now, scientists are having a difficult time modifying their hypothesis about the early cosmos. They are having trouble dealing with the fresh data that was delivered by the James Webb Space Telescope, which is a huge problem. Scientists currently assume that between 100 and 200 million years after the Great Bang is when the first stars started to emerge. These stars had a significantly shorter lifetime, but were much bigger than our Sun, maybe up to 1,000 times more massive than our Sun. Last but not least, the near-infrared spectrograph on the Webb telescope will be able to look at these target objects' temperature, mass, and chemical makeup. Astronomers are sure that this will give a definitive answer about whether or not these things exist. In the meanwhile, we may all wait patiently to find out whether or not our basic knowledge of the beginning of the universe is going to change, and whether or not the existing cosmological rulebook is about to be ripped up. That was all for today's video. We hope you have enjoyed the video. Please feel free to share your thoughts in the comment section. Moreover, if you are new and haven't subscribed to the channel yet, remember to subscribe and hit the bell icon so you won't miss any useful and informative daily videos. Thank you for watching, and best of luck!